So now let's discuss advanced concepts of Aura that you need to know going into the exam. So let's talk about replica autoscaling. So let's say we have a client and we have three Aurora's instances right now. So one will be writing through the writer endpoint, and the other two would be reading through the reader endpoint. Okay. Now let's say that we are having many requests, read requests on the reader endpoint. And so therefore the Amazon Aurora databases have an increased CPU usage. In that case, we can set up replica autoscaling. And what this will do is that it will add, obviously, Amazon Aura replicas. And then what will happen is that automatically the reader endpoint is going to be extended to cover these new replicas. And therefore, these new replicas will start receiving some traffic, and the reads will be happening in a more distributed fashion, hopefully bringing down the overall CPU usage. So this is replica autoscaling. The second thing is custom endpoints. So let's say we have the same setup, but this time we have two different kinds of replicas. As you can see, we have some DB R3 large and some DB R5 2x large. So some read replicas are bigger than others. And the reason you would do this is that you want to define a subset of your Aura instances as a custom endpoint. So let's say we define a custom endpoint on these two bigger Aurora instances. The reason we would do so is, for example, that we know that these instances are more powerful and therefore they're going to be better to run analytical queries on these specific replicas. So when you do so, you have a custom endpoint that's defined. And when you have a custom endpoint, generally the reader endpoint itself is not used after defining custom endpoints. So it would not disappear, but you would not use it anymore. And what you would do in practice, in like practically speaking, is set up many custom endpoints for many different kind of workloads, therefore allowing you to query only a subset of your Aurora replicas. Next, we have serverless. So this is going to give you automated database instantiation and autoscaling based on actual usage, which is great when you have infrequent, intermittent, or unpredictable workloads, and therefore you don't need to do any capacity planning. You're going to pay per the second of each Aura instance that is being spun up, and this can be a lot more cost effective. So how does that work? Well, the client is going to talk to a proxy fleet that is managed by Aura, and in the backend, many Aura instances will be created based on your workload in a serverless fashion, so you don't have to provision capacity at all in advance. Then we have multi-master, and this is in case you want immediate failover for the writer nodes, in case you want high availability for the writer node. In this case, all the nodes in your Aura cluster does read and write versus the idea that you before, if you only have one write node and it falls down, it fails, then you have to promote a read replica as the new master. So here we have three Aura instances. There's replication happening between all of them. There's a shared storage volume, and the client will have multiple database connection. All the Aura instances can do writes, and in case one Aura instance fails, then you can automatically failover to another one, giving you immediate failover for the writer node. And this is the kind of use cases and scenarios that the exam will test you on. Finally, we have global Aurora. So in case we have a Aurora cross-region read replica, it's going to be very helpful for disaster recovery, very simple to put in place, but you can also set up the Aurora global database, which is the recommended way of doing things today. In this case, you have one primary region where all the reads and writes happen, but you can set up to 5 secondary read-only regions where the replication lag should be less than 1 second, and up to 16 read replicas per secondary region. And this will help you decrease latency for the read workloads all over the world, but also in case you have a database outage in one region, promoting another region for disaster recovery purposes has an RTO, so recovery time objective, of less than 1 minute, so it takes less than 1 minute to recover into another region. And here's a sentence you should look out for from an exam perspective. It takes on average less than 1 second to replicate data across region for your Aura global database. So this is something that if you see an exam, it's a hint to use a global Aurora. So let's have a look. We have US East 1 as our primary region, which is where the applications do the read and writes. And then we'll set up a secondary region in EU West 1 where some replication happening with a global database of Aurora. and the applications there can do read only from that setup. But in case US East 1 fails, then we can fail over to EUS 1 by promoting it as a read write Aurora cluster. Aurora also has an integration with machine learning services within AWS. So the idea with Aurora machine learning is that you can have ML-based predictions to your applications via the SQL interface. It's a simple, optimized, and secure integration between Aurora and different AWS machine learning services. So two supported services are SageMaker, which allows you to use any kind of machine learning model in the backend, or Amazon Comprehend if you want to do sentiment analysis. Now, you don't need to be an expert in SageMaker or Comprehend. You just need to know that Aurora has an integration with those. So in order to use Aura machine learning, you don't need to have machine learning experience. And the use cases for this would be to have fraud detection, ads targeting, sentiment analysis, or product recommendation, all within Aurora. So to give you the architecture idea, Aurora is going to be connected to the machine learning services in AWS, and your application can just run a very simple SQL query. For example, what are the recommended products? Aurora will send some data into the machine learning services, such as, for example, the user's profile, the shopping history, et cetera, et cetera. And then the machine learning service will return a prediction directly to Aurora. For example, the user should buy a red shirt and blue pants. And then Aurora can just return the query results to the application all through as a result of the SQL query, which is very handy. So that's it, just a feature you need to know going into the exam. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture.